Well, hello again and welcome to the VK6CS Fun with Amateur Radio channel. To quote Jamie Heineman, I think I've done it before, when will the fun ever stop? Now, if you saw the last video, you would have seen that I got about 800 watts out of this thing. I was hoping to get a kilowatt out of it, but putting 2500 volts on the anode, 840 milliamps of anode current is about 2100 watts input, 800 watts output is rubbish. Efficiency is about 40%, in the order of 40%. So I was rather hoping it was going to be down to maybe optimizing this tank circuit, because this tank coil was given to me. I just put it in the amplifier unmodified just to see what would happen, and found that it actually gave me a bit of a tune. So I thought, okay, well now I've got some numbers to work with. When the 800 watts was coming out of it, I had 840 milliamps of anode current, I had 2500 volts on the anode, so from that I could calculate the anode impedance. The anode impedance came out to about 1.5k, 1.488k. So I put a 1.5k resistor from the anode to chassis, because you probably know, or if you don't know, you can tune these things backwards. So once you've got some numbers to work with, or if you know what the anode impedance is, you can put a resistor across the valve. Just leave the valve in circuit, just put a resistor across it, then stick an antenna analyzer on the output and look back through the tank circuit to the valve and see how good the match is. And I was really super disappointed, because when I did that, I saw that. So that cable there goes off to the RF output on the amp. So sadly it looks good. So I think it's going to be down to this valve not liking 2500 volts. I have read around on the internet that people have made these amplifiers and they've said, don't expect to get anything out of it, anything useful out of it below 3000 volts. I think they're right. From my personal experience, I think that's the problem. I think if I had another 500 volts, I'd get the power out of it. But it looks like this coil's pretty good actually for 80 meters. I mean, it's given me a pretty good tune. That's 1 meg. That's 1 meg wide. That's 1 meg wide. So I don't know. Maybe I might be able to squeak the Q up a bit on it, make it a little bit narrower. Might be able to squeak a bit more out of it. But anyway, that's where I am with it. So at the moment, what I'm thinking is, I'm probably not going to be able to do much better than that with that HT voltage taking down to 2500 volts. That is disappointingly good. So that is looking into the RF out of the amplifier through to the valve, through the tank circuit. If I take the resistor off, let's take the resistor off of the valve anode. It's only on there with a crop clip. There we go. So what I'll probably do, it's probably a good job I made this thing modular, because this is a sort of, this RF stage, this valve stage here is a module, so I can take that out. And maybe I'll put a couple of glass valves in there that are more efficient at that sort of voltage. So maybe a couple of 813s trio-connected, or something else would be far more efficient in that position than that Russian valve. It's either going to be a case of doing that, I think, changing that for a couple of glass valves that are happier at a lower HT voltage, or trying to find a HT transformer that will fit in that space that I've got my HT transformer in, that will give me another 500 volts of HT. I suppose I could try bolstering the HT by putting a lot more smoothing capacitors in, so that it doesn't quite sag down as much. If I could win a couple of 100 volts, that might do the trick. But anyway, that's where it stands at the moment. So, yah, boo, hiss. And back to the FLDX. Well, of course I couldn't run this at more than 400 watts anyway legally, but back to my old trusty FLDX 2000, I think, for the time being. Oh, a fiddle sticks. Thanks for watching. I'll catch you next time.